Today's video is on multiplying decimals. You multiply decimals the same way you multiply whole numbers. Once you have your product, it should have the same number of decimal places as the sum of the decimal places in your factors. Let's count. This problem's already been solved for you, and you can see that in the first factor there are 2 decimal places, and in the second factor there's 1 decimal place. Because that's a total of 3 decimal places, that's how many decimal places would be in your product. If we had multiplied this exact same problem and it had been 316 times 73, our answer would have been 23,068. But because of the decimal places, our answer is 23 and 68 thousandths. Unlike adding and subtracting decimals, you do not need to line up your decimal points when multiplying decimals. Let's take a closer look here. You'll note that in this example over here, for 11.3 times 6.57, I've lined up the decimal points and I've placed a 0 to hold that spot. And you'll notice the only difference between this work and that work is that because of the extra 0, you've got extra zeros in your individual products, and you've got an extra place in your final product. In this example, you'd count 1, 2, 3, 4 decimal places, and so therefore 1, 2, 3, 4 decimal places in your product. Over here, because we didn't have the extra 0, because we didn't line up the decimals, we only have 1, 2, 3 places in our product, in our factors, so we only have 1, 2, 3 places in our product. Either way, our answer is 74 and 241 thousandths, or in this case, 74 and 2,410 ten thousandths. But remember, this 0 we would drop anyway because it doesn't add any value to the number. There's 0 value in the 10 thousandths place. So either way, our answer would be 74 and 241 thousandths. It's a great idea to use estimation to check to see if your answer is reasonable. Because the rules are different with multiplication than with subtraction and addition, if this had been an addition problem, you would have just brought your decimal point straight down. But an answer of 776 would have been very unreasonable when really you're just multiplying 2 times 3 here. So if you estimate, round to the place value to make a common number for multiplication, you'd get an estimate of 6, which is pretty close to 7.7665. So that indicates to you that your place value is correct. Now, many people might be like, well, 6 is pretty far from 7.7, and it is, but it's the place value that you're checking here, because most of the problems with multiplication of decimals have nothing to do with multiplication, but to incorrect decimal placement. So what this does is it validates that you have the correct decimal placement for this answer. It doesn't guarantee your answer is correct, but it does tell you that your answer is in the correct place value or the correct magnitude. Straight simple problem. We all know that 3 times 5 is 15, but because of the 1 decimal place, then we would bring that decimal point over 1 place to get an answer of 1.5. And that makes sense, because when you multiply point something times a whole number, your answer is going to be smaller because you're multiplying by a number less than 1. In this example, both factors have a decimal. We can multiply this the same way we would have multiplied 23 times 7. 7 times 3 is 21, carry the 2. 7 times 2 is 14, plus the 2 is 16. Now, because we have 1, 2 decimal places in our factors, we're going to have 1, 2 decimal places in our product. Our answer will be 1.61. And again, we're multiplying 2.3 times 0.7. So we're multiplying by a number that's less than 1. We should anticipate that our answer should be less than our original factor of 2.3. In this example, we have multiple items in our decimal places, in our factors. So we're going to just multiply this out just like we would 81 times 62. 2 times 1 is 2. 2 times 8 is 16. 6 times 1 is 6. And 6 times 8 is 48. We'll add up, and we'll get a total of 5,022. We can't forget our decimal places, though. We had 1, 2, 3 decimal places in our factors, so we should have 1, 2, 3 decimal places in our product. Your answer would be 5 and 22 thousandths. Now here's a word problem just to give us an idea of how we would handle this. And let's stretch that out so you can see the whole problem. Good. So your new job pays $6.70 per hour. You work 2.5 hours or 2.5 hours. How much money did you earn? Just like if you'd been paid $7 an hour and you've been working 2 hours, you would just multiply to get this answer. But now with your newfound knowledge of multiplying decimals, we know that we don't need to line up our decimal points when we multiply $6.70 times 2.5. 5 times 0 is 0. 5 times 7 is 35, carry the 3. 5 times 6 is 30, plus 3 is 33. 2 times 0 is 0. 2 times 7 is 14, carry the 1. 2 times 6 is 12, plus the 1 is 13. Make the sum of each column. Now, we clearly didn't make $16,000 on this day when you worked 2.5 hours. And again, that's because we've got to represent the 3 decimal places in our factors by placing those 3 decimal places in our product. The correct answer would be $16.75. Now, as we move forward, there's one last word problem, and this is a multi-step word problem, so we want to be very careful with this. It says, boxes of tissues cost $1.47 each. If you buy 6 boxes, how much change will you receive if you give the clerk $10? Well, our first step is to find out how much it costs for these boxes of tissues. So since each box costs $1.47, we're going to multiply that by the number of boxes you want, which is 6. So 6 times 7, 42, carry the 4. 6 times 4 is 24, plus the 4 is 28. 1 times 6 is 6, plus the 2 is 8. So because there are 2 decimal places in our factors, there are 2 decimal places in our product, we are going to pay $8.82 for the 6 boxes of tissues. Now, remember, we're subtracting this from $10. So $10 is how much money we have, and following the rules for addition and subtraction with decimals, we do need to line up the decimal point. And in this case, we will need to borrow because we cannot subtract 2 from 0. So there's no value here, there's no value here. We've got to go all the way over here. So this 10 would become a 0, and we'd have 10 in the ones place. We can't subtract this yet because we need to borrow from this 10 to subtract here, and we need to borrow from this 10 to subtract here. So now we can finally subtract. 10 minus 2 is 8. 9 minus 8 is 1. 9 minus 8 is 1. 0 minus 0 is 0. We bring our decimal point straight down with decimal subtraction, and we know that our change, you would receive $1.18 in change. All right, thanks for sticking around till the end.